Welcome to the Fall 2010 open house for the Robotics Club. Tonight we're just going to go over basically what the club does and what the plan is for the upcoming year. So just a little bit about the club. It was founded in 2004, and the mission is to give students a forum in which to learn about and build robots. And I just want to briefly go over the executive team this year so you can familiarize yourself with the people that are kind of in charge of this. So I'm John Chekin, I'm the president. Just a little bit about me. I'm a senior. I'm actually majoring in microbiology, and robotics is just kind of a hobby of mine. It's something I've been involved with since my freshman year in this club. The vice president is Jillian Newhall.
Hi.
Secretary is Drew. He's somewhere around. He's somewhere. He left. He'll be back. The treasurer is Jessica. She's over there. The webmaster is Marshall. Right there. And our quartermaster, Rich, he is actually on a co-op right now, so he will just be around on the weekends for the club this year. So this is basically our meeting time and place right here and right now. This year we're going to change it up a little bit. In the past we've started at 7 o'clock, and this year we're just going to open the doors at 7 and probably not start until 7:30 or 7:45. That way you'll have some more time to get here, maybe eat some dinner before you get here. Or if your classes run a little bit late, you have time to get here and not be able to miss what we're doing. But you can still get here at 7 and start working. So the first thing is, what is a robot? And I'm sure you probably all have some idea of what it is. But basically what we try to do is make autonomous vehicles. So instead of doing RC robots, which I'm sure you've all seen, you have remote controls and there's not much programming involved. For us, we really want to make robots that think by themselves, that are able to react to different kind of environments, get through mazes or obstacle courses, and actually accomplish goals without us having to tell them exactly what to do. So that way they're able to adapt and actually be more useful in the real world. So as I said before, our club basically designs, builds, programs, and deploys autonomous robots. And we have 3 main goals in our club: teaching, competing, and then just having fun. So the first aspect is teaching. So I'm sure you all have very different backgrounds. Some of you maybe have advanced training in programming, in electronics, and so you may start out at a different level than someone maybe who has never seen or actually done robotics before. So for this reason, we offer intro lessons for the first 3 meetings. So essentially what we do is we give you a chassis that looks something like this, and we'll teach you the basics of all the different sensors we use, how to program, and just the electrical components involved in actually making a functional robot using this basic chassis. And also, we actually have a RoboWiki, and what this basically is I'm sure you're all familiar with Wikipedia, and this is just basically a small Wikipedia basically that we made that contains the information about all the sensors we use, the different kind of programming language we use, and the different microcontrollers we use. So essentially, you're going to be able to look up look up the information whenever you want at home, or just it can be a reference for you whenever you're building these. But there will always be people in charge here to help you along, just in case you need extra help. So we have 3 different levels of competing. The first is the tabletop robotics. So that will be this sort of chassis. You use something like this. And we have 2 different competitions: the fall and then the spring. In the fall, we're going to do a capture the flag competition. And this is something we did 2 years ago and 3 years ago. And the goal is basically to start in your base, navigate through a maze, grab a flag in the opponent's base, and come back. So it utilizes different types of components, and it's a good introduction. In the spring, we're going to do the firefighting competition, and we're going to have a small competition that we're just going to host here. And essentially, it's modeled after the Trinity Firefighting Challenge, which I'll talk about in a minute. But essentially, the goal is just to find a candle in a maze, put out the candle, and return back to base. And both of these competitions, as I said, they're held within the club, so you're just competing against your fellow club members. The next competition, as I just mentioned before, is the Trinity Firefighting Robot Competition. And this is actually held in the spring in Hartford, Connecticut. And this year we're going to do it a little bit differently than we have in the past. Previously, we've had people try to build a robot in one semester and compete against teams from all over the world that have been using the same robot year after year. So as you can imagine, their robots were very good and quite impressive. And us only being able to do it in one semester, it was kind of difficult to compete on that level. So this year, we're actually going to try to focus our energies into maybe 1 or 2 robots, possibly using this one, a walking robot, and compete in the actual walking competition there at Trinity. And this robot will be used year after year, and essentially we're going to try to compete and win these kind of competitions. And so, as I said before, there's going to be 1 or 2 teams, and we're going to try to start these in the beginning of the year. So this would be something you'd work on throughout the entire year. So you can speak to me or one of the other officers if you're interested in being on one of these 2 teams. The next competition, which is the highest level we have, is the IGVC, and Anthony wants to talk about this.
So this is a competition for more the advanced users, but that's not even true. I mean, we brought in last semester, we had freshmen working on the team. We try and teach you, but definitely the level of competition is a little bit higher. What we do here is we focus on the IGVC, the Intelligent Ground Vehicle Competition, and what we do is we drive outside, navigate waypoints, have to avoid obstacles, and there's even a lane following where there's a lot of obstacles and you have to follow the path, not drive over, and stay on the road. And as you can see, they run it outdoors, rain or shine, so you have to be prepared for that. It means you have to design something well enough to operate in the rain and make sure that you can still see and stay dry. Our method 2 years ago was trash bags. This year, again, we did trash bags. So we have different opportunities. What you'll see is this is a pre-built package that we borrowed from one of the professors here on campus. And then what you can see if you come over afterwards, we built our next platform from the ground up. So those that like building things, we started from scratch and tried to design the thing, engineer it properly, and put it all together. So there's both the mechanical side and there's also a programming challenge. And here we have grad students that usually work on the competition, and so we try and act as a mentor towards the team. And then we have the freshmen, hopefully undergraduates, learning to figure out how to do this on their own and eventually take over when you guys get to the point. So I don't want to delay it too long. If you have questions, talk to me afterwards.
And finally, in the past we've done the Mini Grand Challenge, which is essentially a smaller version of the DARPA Grand Challenge. And the goal is to navigate the Penn State Abington campus. And this year, we're actually going to be changing that also. It's just going to be utilizing the IGVC robot and just changing the programming to adapt it to this competition. So actually, these pictures are from previous years, so we won't actually be using that robot. And the last thing, as I mentioned, the third goal is to have fun. And we do this with club socials. So in the upcoming weeks, we're going to have Ultimate Frisbee, we're planning a StarCraft night, and in the past we've done a broomball night. And also, in the past we've got club gear. So we've got shirts, polos, and hoodies previously, and we're going to try to do that again. And the final thing I want to mention is the website. We have a pretty well-developed website, and as I mentioned before, the RoboWiki is on here. There's a direct link from the website. We have club news, we have the media, so we have pictures and videos of the robots that have been made in the past. We have a mailing list, so you get our spamming emails. There's a calendar that tells you the meeting times, any kind of upcoming social events, or just what's the upcoming plans. And also we have a source code version control, so essentially, I know the Mini Grant has used this extensively in the past, where they everyone uses the source code that's available on the website. And actually, other schools have actually adopted some of the code that we've written in the past. So that's kind of interesting. And again, our website is just psurobotics.org. And so for you, why should you stay around? The first reason is the club is free. There's absolutely no dues at all. We provide all the electronics, all the components. All you need to do is be interested. We have all kind of, you don't have to have any sort of level of expertise. We'll teach you from the ground up. But even if you do have a lot of background, you can work on the higher level robots, or even just try to do these tabletop robots if you're interested in that as well. And again, we want to emphasize that all majors are welcomed. I'm microbiology. I'm not an engineering major. I do this for fun, and that's just the main reason why any of you should be doing it. Again, we have new member training, so even if you don't have any experience, we'll teach you what you need. And we're basically one of the only robotics presence on the club. So if you want to learn about robotics, you have to basically come to us. And again, this is great if you're looking for actual reasons, maybe on your resume. It's great for your resume. There's been companies that exclusively asked just what is the robotics club, and they've been really interested in that. For seniors, there's big projects, something, again, to put on your resume. And if there's any graduate students, you can do research-related work, such as the IGBC, because we have 2 graduates working on that already. So if you have any general questions, you can ask me now, or you can we'll be around for, a while. So you can just ask us, come up to us and ask us questions. Again, Jillian's right there.
Hi.
She's the vice president.
Come talk to me.
Drew is still not here. Not coming back. He's actually working on robots, from what I'm told. Jessica's over there. And I'm John again. Right, thanks. Oh, question,
Jeremy.
yes.
Sure, just 2 quick questions. That Trinity firefighting competition, is it an international competition?
Yeah,
or?
as I mentioned, it's an international competition. People come from all over the world. There's people from China, Israel, everywhere.
And then also another question, do you have like legacy students or students that have come back to help others? Like advisor?
We have, I'm sorry, what?
Like advisor students?
Yeah, so obviously all the executive team, they've all done these kind of robots before, so they'll be a good reference. There's other, so Jeremy over there, he is a super senior, so he's good for questions. Anthony, who's the one that was talking about the IGBC, he's good for questions. There's just a lot of people here that have been around for a while, and they're a good resource to take advantage of. Any other questions? All right. So,
What's the next step? What's the next step if you're interested in being involved?
Next step is just coming to our next meeting,
Which is-
this time it's every Wednesday at 7. We'll start the actual tutorial at like 7:30. The first tutorial is, I believe, motors or
yeah,
locomotion. Okay, so by the end of the night next week, you will actually have a robot that will be able to move. So and don't be scared if that sounds like it's too difficult. We've had people pretty much like 95, 100% success rate in the past with that tutorial. It's pretty much guaranteed you will have a working robot by the end of the day. So that's pretty exciting. So if you're interested, just come here next week, see what it's all about, start working on a robot, see if you like it.
Yes, we're